Essential thrombocythemia, or myeloproliferative neoplasms. What are myeloproliferative neoplasms? Myeloproliferative neoplasms, MPNs, are a rare type of blood cancer which consists of three major types. Polycythemia vera, a disease of the bone marrow. It is usually where there is an overproduction of blood cells, usually red blood cells, though white blood cells and platelets may also increase. Essential thrombocythemia. Essential thrombocythemia is a blood disorder in which there is an overproduction of platelets in the bone marrow. In primary myelofibrosis, a disorder of the bone marrow that disrupts normal production of blood cells, it causes an excessive amount of scarring in the bone marrow, along with a low blood cell count. My mom, who was age 45, discovered she had myeloproliferative neoplasms last year at age 44. The mutation was discovered through a regular routine blood test. It was confirmed she had essential thrombocythemia through a bone marrow biopsy. She goes through more regularly assigned blood tests now to monitor her and make sure her platelets, red and white blood cells, and hematocritic cells stay in a healthy number range. Her treatments have consisted of phlebotomies, which are pints of blood taken to lower her numbers, and medication, which consists of daily aspirin to thin her blood, and hydrea, a type of mild chemotherapy. Hydrea also helps combat the low iron she is prone to having due to phlebotomies. Her common side effects that are induced by essential thrombocythemia are headaches, extreme fatigue, easy bruising, and itchy skin. At the moment, her blood cell numbers are stable and average, though it took some time to get there. Around 1 to 24 per million people worldwide are affected by thrombocythemia. So how have mice helped combat this disease? Attica and colleagues were the first to report a conditioned mouse model where the mouse JAK2 V617F expression was controlled by the dwelling JAK2 promoter and could be induced by PIPC treatment. In the experiment, the knock-in alleles were generated by inducing a V617F mutation construct with a PGK neo-stop cassette into the intron 12 of the mouse JAK2. After the treatment, it was discovered that heterozygous mice developed a PV-like phenotype. The expression of mRNA that was encoded into the JAK2 V617F mouse mutant was only 50% of the levels of wild type. However, the homozygous mice developed a PV-like disease as well that showed signs of accelerated bone marrow fibrosis and higher platelet counts. Lee and co-workers' model showed a 5 to 10% chance of a disease progression to PV or myelofibrosis. Because of these tests, it is presumed that another additional genetic event usually occurs to enhance cellular progression, suggesting further need for research in this area. Humans have been found with genetic alterations as well as MPNs, like TET2, MPL, ASCL1, CBL, EXH2, and IDH. My mom also has mutations with her MPNs, like JAK2 and TET2. Here are some other examples of how mice have helped us further understand myeloproliferative neoplasms. Myeloproliferative neoplasms were first discovered in 1951 and have been deeply researched throughout the early 2000s until this day.